You weigh your dose, you tamp perfectly level, and you pull the shot. But instead of a single syrupy stream, the espresso violently sprays in 3 different directions. And when you taste it, your mouth puckers from a sharp, sour acidity, while a harsh bitterness coats your throat. When a shot fails in both directions, it's rarely a sign your machine is broken. You might assume the pump is faulty or temperature unstable, but the culprit is much smaller. If you search for a fix, you'll find a wall of contradictory advice. One forum tells you to upgrade to a grinder with flat burrs. A video says you need a $50 needle distribution tool. Another insists you have to start keeping your coffee beans in the freezer. Blindly following these tips often leads to wasted money. Most of these hacks are highly hardware dependent. They add tedious steps to your morning routine that might not address the physics of your specific equipment.
The real variable controlling the flavor in your cup is your ground coffee's particle size distribution. It is the physical makeup of the grounds before water ever touches them. To fix your extraction, we have to map out exactly how your grinder's internal geometry determines the effort you put in every morning. We'll use laboratory data to see which extreme prep methods work for specific setups and which are a waste of time. Achieving perfect espresso isn't about buying the most expensive gear. It requires matching your workflow techniques to the physical realities of your specific grinder. Almost all espresso grinders fall into 2 geometric categories: flat burrs and conical burrs. A flat burr grinder produces a monomodal particle distribution. This means the coffee grounds are mostly uniform in size, with a lower percentage of microscopic dust, known as fines, typically making up only 15 to 30% of the dose. These uniform particles deliver high flavor clarity and a predictable extraction. The trade-off is that they often result in a thinner body in the cup and cost significantly more than their conical counterparts. Contrast that with a conical burr grinder. It creates a bimodal distribution with 2 distinct peaks, one for coarse particles and another for microscopic fines, which can account for up to 35% of the grind. This chart from the Zurich University of Applied Sciences shows curves representing coffee particle size distribution. The primary peak on the right represents the main boulder size of the coffee grounds, but that secondary hump on the left side is the accumulation of microscopic fines. This bimodal spread is exactly what produces the rich, heavy, traditional espresso body that many people prefer. Neither burr is inherently superior. They simply produce different physical particle structures that require completely different handling. For conical burrs, that high volume of fines introduces a significant mechanical risk: channeling. Channeling happens when highly pressurized water finds the physical path of least resistance through your compacted coffee puck. This is how you get that dual sour and bitter flavor. The water severely over-extracts the coffee directly touching the channel, while completely ignoring the dense, dry clumps, leaving them sour and under-extracted. The first baseline fix is the Weiss distribution technique, or WDT, using fine needles to stir the grounds in the basket. Stirring physically breaks up the dense clumps of fines and boulders before you tamp. This evens out the density of the puck, so the water presses through the whole bed at once. It adds about 15 seconds to your routine, but it is a mandatory low-cost step to prevent severe channeling. If you own a conical grinder, skipping WDT ensures you will battle channeling forever, regardless of which beans you buy. Then there is the most controversial workflow hack: freezing your coffee beans before grinding. Freezing makes the coffee beans highly brittle, which changes the physics of how they shatter under the force of the burrs. To see if the extra effort is worth it, we can look at the Clive Coffee empirical test results measuring extraction yield. For conical burrs, freezing reduced excess fines so effectively that the extraction yield jumped from 18.1% to 18.9%, a significant 3.9% boost in extraction. The trade-off is the logistics. You must use airtight single dosing, as keeping an open bag in the freezer creates condensation that ruins beans. For flat burrs, the impact was smaller. Because they produce uniform particles, freezing only yielded a marginal 1.5% increase. Freezing beans is an incredible cheat code for conical burrs, but it's an unnecessary logistical nightmare for flat burrs. To stop pulling sour and bitter shots, you have to match your daily workflow to your specific hardware profile. If you are a budget optimizer, keep your current conical grinder. Just commit to WDT as a mandatory part of your puck prep. If you want flat burr-like clarity without spending $1,000 on new gear, freezing your single doses is your best path forward. If you are a precision chaser who already owns a flat burr grinder,
Skip the freezer entirely. Your monomodal distribution is already doing the heavy lifting, so you should focus strictly on level tamping and precise dose weights. If you are a gear upgrader buying a new machine, your choice of burr shape determines both the texture of your coffee and the complexity of your morning prep. Choose flat burrs for high clarity and low daily friction. Choose conical if you want heavy body and don't mind meticulously fighting channeling every morning. Perfect espresso is achieved when you stop fighting your hardware's physical limitations and start deliberately optimizing around them.